So guys, this is the Polyglot programmer, and today we're gonna go through this problem which is called validated binary search tree, or BST if you prefer. And this is a very nice problem if you want to understand what is a BST and what are the rules that it has to follow. So let's get right on it, all right? So okay, so basically, given a binary tree, determine if it is a valid BST. All right. So what is a BST? A BST is, uh, depending on the problem or the situation, you might find a tiny difference between the rules. Now explain which ones. But for sake of this problem on Leetcode, this is what we're gonna work with. So the left subtree of a node contains only nodes with keys less than the node key. So that means that everything on the left needs to be less than the max value. What is a max value? Max value is it is the current node value, right? So we're here, so if we go to the left, 1 needs to be less than 5. So the maximum value that 1 can be is 4. If it's 5, it's wrong. So what else? And the right subtree of a node contains nodes that contains only nodes that keys are greater than the node keys. So that means that everything on the right need to be more than the mean value. And the mean value, the same property applies. So why I'm using mean value and max value, you will see in a minute when I start talking about the implementation. So let's talk about this. So for example, this is false. Why? Because everything to the right, so 4 is to the right of 5, right? So everything right needs to be more than the mean value. Mean value of this is the current node, and 4 needs to be more than 5. So 4 is less than 5, then it's false. Okay? And how would we solve this? One way to solve this is using two things, two techniques which are quite useful to know. One is recursion. So we're gonna keep calling the same function inside itself, and we're also gonna use dividing counters. So we're gonna solve one side at a time, and then we're gonna solve the other side. And if this side returns false, then we don't even need to go to the other side, right? So we divide the problem, right? So to solve this, so let's talk about it. So let's define a helper function that takes a node, mean value, and max value, right? Inside this function, first thing we need to do is check if node is none. So let's say that we're here and we call this and if the node is none, that means that you're at the bottom, you're in the leaf node, so that means that it's true. So then return true. After this, we check if the current value is valid using this properties, these rules, and then we're gonna define two Boolean. We don't need to define the variable, but we're gonna do it just for sake of readability, and it's easier to see what's going on. we could have, especially using Python, we could have done this. We could do this just using like a 1 or 2 liner. But I don't want to do that. It's more complicated to read, and this is more straightforward. 2 Boolean variables, two for each side, for each one for each side. Okay. And if left, if no dot left is not none, call the helper function. And if left is true, so if whatever we got from the left side is true, and is not none, call the helper function on it. And then we return left and the right boot Boolean values. So why is this? Because let's say that we're here. So let's say that this is 6. So we call this is 6, then we return false. We don't even need to go here. We don't even need to check all this because we already know that it's not a valid BST. So let's get with it. Let's start doing this. So in this function, all we're gonna do is just return helper. Let's call it that helper BST. Helper, we're gonna pass root, and we're gonna pass a min and a max value. The min and the max value that we're gonna use here is the minimum possible value here. We're gonna use min infinity, and max, we're gonna pass max infinity. Okay, now we're gonna need to define our helper function, helper BST is a class on itself. No, I'm not gonna declare the types here, we don't need it. It is max value. And I like to kind of follow this. Okay, so done. Check if the node is none. So if node is none, return true. Okay. Done. Check if the current value is valid. Okay, so if node value is less or equal than mean value, or node dot value it is more or equal max value, we return false. This is where a little bit of clean coding and proper variable naming comes handy, because like in this situation here, we don't even need to think about it too much. We just know that the value cannot be less than the minimum value, and the value cannot be more than the maximum value. This is obvious. So that's where variable naming comes in really handy, and people sometimes don't give proper value to it. So define two Boolean variables. Okay, so here we're gonna call left. That's left side, right side. Let's start this to true. Okay, doing good so far. So if left is not none, call the helper function on it. Okay, so if no the left is not none, call, oh, we need this in here, helper BST, no the left. And now we need to pass the minimum value for this. The minimum value, we can just pass whatever it was on a minimum value. So in this case, let's say if it's in the first one, it's going to be less infinity because we don't have a minimum value here. We could have whatever left minus a million and it will still be valid. So, and for the maximum value, we would pass no dot value. So the maximum value for this guy is whatever is in here. Maximum value for this guy is whatever is in here, right? And then we do another if. We don't do if else because we want to go through both of them. If left side and node on right is not none, then we call the same thing here. We call the right side, and this time we do have a minimum value. So if we're on the right side, everything needs to be more than whatever I'm current value. So then we do pass the node value here, node value as a minimum value, and we just pass along the map, whatever's on the maximum value. And here we return left side, right side. I just saw a mistake here. So I'm defining the Boolean variables here. I'm calling it here and I'm returning it here. This will always be true because I haven't changed them. So I'm just gonna assign them here. So left side. And right side. And should be fine. Oh, sorry. Yeah, this is on me. Yeah, no. Max value. So this. I'm using to use. I'm used to use value. Leetcode for some reason there's just val. Just, dude, guys, change this, please. No, another mistype. So where did I miss this? Node. Yeah. Okay, this is good. Let's submit it. Accepted faster than 52%. Less than 99.10% of memory. This is pretty good, right? So worst case scenario of this time will be O of n, because worst case scenario is that we will have to check every one of them. Average VO log n, because like I said, sometimes we can, if we solve the problem on this side, we don't even need to go to that side, right? And for space, this is actually O of V, where V is just the it's a vertices, right? So every time that we call a function here, this gets added to the stack, and it just increases the space. So that's it. That's it for this one, guys. I hope you guys enjoyed it, and see you next time.